Welcome to an introduction to educational research. Today's video will be dealing with 4 different types of random sampling. So some definitions and purposes here. Sampling is the process of selecting individuals for a study in such a way that they represent a larger group, the population from which they are selected. The purpose of any sample is to gain information about the population from which the sample was drawn. So a researcher is faced with wanting to make some generalizations about a population. And so they sample from that population. And then they conduct a study, and then they'll draw inferences on the basis of that sample. And if it's a good, solid study, and they're able to generalize back to the population, then they get some information about the population. Rarely do researchers use an entire population to gather their data. Generally, it's not possible. It can be very, very expensive, especially if it's a large population. Very time-consuming. And on many instances, it's not even necessary. You'll see an example in a screen or two where to sample the entire population would not even be necessary. One rare instance that the entire population is attempted to be sampled is in the census. Every 10 years we have a census, and the government attempts to contact everyone in the population. If a sample is well selected, research results based on it will generalize to the population from which it was drawn. So this video is going to discuss several sampling strategies that can be applied to select a representative sample. Awareness of these strategies will assist you in critically reading and analyzing research and interpreting the results. When you're reading some of your research articles, you should be asking yourself, if it's appropriate, where did this sample come from? How was it drawn? Because that's important to know in terms of how generalizable the results of the study will be. Okay, so a population is the group of interest to the researcher. It's the group to which the researcher would like the results of the study to be generalized. And some examples of populations might be all 11th grade students in the United States, all behaviorally disturbed students in the state of California, all students classified as autistic in Contra Costa County, California. Those are examples of populations that researchers may be interested in taking a look at. The target population is the entire group the researcher would ideally like to be able to generalize the results of the study to, and rarely is this population available to the researcher. As an example, if we wanted to study the population of all 11th grade students in the United States, that would be way, way too large a population to be able to study. That's the target population. Now, the accessible or available population is the population that the researcher can realistically select. 11th grade students in 2 high schools in Napa County, California. That could be an accessible population. In most studies, population selected is the accessible one or the available one. As mentioned previously, selecting a sample is extremely important in conducting a research study. The goodness of fit of the sample determines the meaningfulness and generalizability of the results. A good sample is one that's representative of the population from which it is drawn. That's the most critical piece, that it's representative. Not necessarily it has to be a large population, a large sample. A good sample, first of all, has to be representative. Steps in obtaining a sample: identify the population, target versus accessible population, determine the required sample size, and select the sample. How large should the sample be? Well, in terms of determining the required sample size, there's been some research done. Here is the source of this. And there's actually a research article, and it has a table. I've only reproduced part of that table here, which shows you the population and then the sample size that you would want to sample. So for an example, if your population is 10, you have to sample all 10 of them. If it's 15, you sample 14. If it's 20, 19, 25, 24. So you can see if the sample size is relatively, if the population size is relatively small, like 35, you need to sample 32 of those. And as you go down, if it's 75, if the population is 75, then you need to sample 63. And then I took some other pieces of the chart. So here the numbers go up a little bit. So if the population is 280, the suggested sample is 162, and 290, 165, and so on. 380, the population, the sample size they're suggesting is 191. But as you get up into the larger numbers, if you have a population, if you have a population of 2,800, then the suggested sample size that you use is 338, and so on. And so a population size of 6,000, they're suggesting that sample size should be 361. So you can see as you get up into the larger numbers, the larger the population, then sort of the less the sample size is, or the difference between population and sample size. When the population size is very small, you're sampling almost the entire population. As the population size gets larger and larger, you're sampling less and less. And in selecting a sample size, again, it's not the size of the sample. It's not the size of the sample, it's how representative the sample is. As an example, the Nielsen ratings, which are the television ratings, Nielsen collects data on what the country watches in terms of TVs. They have some electronic ways of doing that, and they do it by diary also. But there are 99 million households that have televisions in the United States. So 99 million households. They use a sample size of 5,000 out of the entire population of televisions in the United States, which is 99 million. So it's a very, very small sample size. In fact, it's approximately 0.5%. But it is so representative that they get very valid results. In fact, advertisers spend billions and billions of dollars each year, advertising dollars each year, based on the Nielsen ratings. So again, the key thing in selecting a sample is that it is representative of the population from which it is drawn. And so we're going to look at, and the best way to do that is random sampling. So we're going to look at 4 types of random sampling: simple random sampling, stratified, cluster, and systematic. So let's take a look at simple. Oh, well, this is still random sampling. Random sampling is the process of selecting a sample from a population in such a way that all the individuals in the defined population have an equal and independent chance of being selected for the sample. So that's a key thing about random sampling. Everyone has to have the same probability of being selected. No sampling technique can guarantee a representative sample, but random sampling is the best. The probability of achieving a representative sample is highest with random sampling. I'm going to show you a little example here where we have 20, population here is 20. It's 10 males, 10 females. When I click on this button, it's going to randomly select 10 of these, but randomly. So if it randomly selects and we get 5 males and 5 females, well, that's excellent. That's very representative because that's 50%, because we have 10 males and 10 females. If we got 6 and 4, that's not bad either. That's 40% representative. But if we get 1 male and 9 females, that's very, very poor. So let's run through one time here and see. Okay. So it selected randomly from these 20, and this is what it chose, and it's 5 males and 5 females. That's exactly representative. Let's try it again. Now we got 3 males and 7 females. You'll notice down here that's a poor fit. It says poor fit equals 1. Let's try one more. 5 and 5 again. That's perfect. That's perfect representation. Well, now let's try where we're going to do 50 iterations of this. 50 iterations of selecting 10. And it'll take a minute or so, but it's not bad. So let's watch it. Okay, that's 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, so 50 times it randomly selected 10 males or females from this list of 20. And here, 15 times it was a poor fit out of the 50. So 30% of the time was a poor fit. So 70% it was a good fit. So basically what that's saying is if you use random sampling, you're guaranteed at least 70% of the time to have a really, really good fit. And that seems to be the best that we can do. So random sampling is the way to go, if possible. In most instances, it's not. Okay, now we have stratified sampling, equal size and proportional. Stratified sampling is the process of selecting a sample in such a way that identified subgroups in the population are represented in the same proportion that they exist in the population. Proportional stratified sampling would be appropriate if you were going to take a survey prior to a national election, let's say, which is very timely right now, in order to predict the probable winner. You would want the number of Democrats, Republicans, and Independents in the sample to be the same as in the population. So, for example, if Democrats make up 46% of the population and Republicans make up 40% and Independents 14%, then you would want 46% of the sample to be Democrats, 40% of the sample to be Republicans, and 14% of the sample to be Independents. Of the likely variables for proportional stratified sampling, other likely variables, race is one, gender, religion, socioeconomic status. These are all good candidates for a for a proportional random sampling. So that's then breaking your population up into its groups and then selecting a random sample of the proportion of that group, of each of those groups that exists in the population as a whole. And then stratified sampling, or equal size sample, would be most useful if you wanted to compare the performance of different subgroups. As in here, I'm going to give an example. Suppose we were interested in comparing the achievement of students of different ability levels. So we have high, average, and low ability. And they're being taught by two methods of mathematics instruction, teacher versus computer assisted. So the stratified sample might look at it like this. Our population is 300 eighth graders. Of those 300, 45 are high IQ students, 215 are average IQ students, and 40 are low IQ students. So that makes up a total of 300 students. Now, we randomly select from the 45 high IQ students 30 students. We randomly select from the 215 average IQ students 30 students, and we randomly select from the 40 low IQ students 30 students. So now we have three groups of randomly selected students, and then we randomly assign 15 of the high IQ students to the teacher instruction, and we randomly assign 15 to the computer instruction. And the same with the average students. We randomly assign 15 of those 30 to teacher and 15 to computer assisted. And the same with low performing students. We randomly assign 15 to the teacher instruction and 15 to the computer instruction. So that's an example of a stratified random sample. And of course, the first example was an example of the proportional stratified sampling. Okay, let's move on to the next one. And this is cluster sampling. Cluster sampling uses randomly selected groups instead of individuals. So it's not randomly assigning individuals now. All members of the selected groups have similar characteristics. Example, all 9th grade biology students. As an example, rather than selecting all 9th grade biology students in a large school district, you could randomly select 9th grade biology classrooms and use the intact classrooms as your sample. Any place you find an intact group with similar characteristics, that's considered a cluster. And examples might be classrooms, schools, city blocks, hospitals, local bars or saloons. These could all be considered clusters. The advantage is it's most useful when the population is very large or spread out over large distances. Also useful when it is not feasible to use any other method. Inability to select and assign individuals or break up classrooms. Like we couldn't go to a school district and say, okay, we want to study our 8th graders and we want to break up all the 8th grade English classes and randomly assign them to classes. That would just create havoc. So cluster sampling using existing groups or existing classrooms in this case would probably be the way to go. Usually involves less time, less expense, and it may be much more convenient. So here's, and by the way, here's a picture or a little graphic. Each of these is clusters and 2 of them were randomly selected, this one and this one. All right, let's consider this hypothetical scenario. For your master's thesis, you would like to survey all teachers in Solano County on their morale, their sense of what their morale is. So again, this is all made up. There are a total of 5,000 teachers in Solano County School District. I made that up. And you need a sample of 50. Okay, so there are 5,000 and you need to have a sample of 50. There are 100 schools in the Solano County School District, also made up. Each of the 100 schools averages approximately 50 teachers. To figure how many schools you would have to select, you divide the sample size, which is 500, by the number of teachers per school, which is 50. 500 divided by 50. So you would need to sample 10 schools. You would need to randomly select 10 schools out of the 100 schools in the district. 10 of the 100 schools in the district are randomly selected to participate. Your research sample equals all teachers in the 10 randomly selected schools. So that's an example of cluster sampling using existing groups. And again, we as teachers will probably encounter this by using existing classrooms or existing schools. And then let's take a look at systematic, which is the last one we'll look at. Systematic sampling is sampling in which participants are selected from a list by taking every kth name, k being a number determined by the size of the list of participants and the desired sample size, and we'll see this in a minute. As an example, if k equals 20, then sample selection involves randomly selecting a name that's on the list. So let's say you have a list of 100 names or 1,000 names. You randomly select one name, and then you take every 20th name after that name. So let's assume you randomly selected the 10th name. So then you would take the 20th after that. So you'd take the 30th name, the 50th name, the 70th name, the 90th name, the 110th name. So every 20. The main difference between systematic sampling and the others discussed is that all members of the population do not have an independent chance of being selected for the sample. Once the first name is selected, then in the list, then all other names are automatically determined because you're taking, in our example, every 20th name. However, systematic sampling can be considered random if the list that the names are chosen from, if it's names that we're doing, if the list is in random order, then it can be considered random. The major objection to systematic sampling is that a major group of population can be systematically included or excluded. My last name is Johnson. If we were using a phone book and we were taking every 100th name, that was going to be our sample. Well, there are many, many Johnsons. So Johnson would appear a lot, whereas there may not be as many Kaminskis or some other unusual surname. And so this entire group might be skipped over. There might not even be 100 Kaminskis in the phone book. So that's one of the disadvantages. And an example, let's say the population, 5,000 teachers in Solano County School District. Sample we want is 500. This is the same example. So we have an alphabetical listing of all of the 5,000 teachers in the district. So we're going to say K is equal to the population size divided by the desired sample size, 5,000 divided by 500, which is the sample size. So that equals 10. So now K becomes 10. So a random name is selected from the list of all of the 5,000 teachers, and then from that point, every 10th name is added. If it was 5 that was selected, then it would be the 15th, the 25th, the 35th, the 45th, and so on. And so that's an example of systematic sampling. Here is a sort of a diagram that points out the advantages and disadvantages, and I think we have already talked about that. I will let you put the video on pause and let you take a look at this if you would like to. And then when you're finished looking at it, turn the video back on again. Okay, and each of these diagrams is designed to give sort of a visual of what the sampling techniques are. This being this is a table of random numbers, by the way. A lot of times that's used in simple random sampling. This is an example of the stratified. This is an example of cluster and systematic. Well, good. Okay, your turn. So create a Word document and name it your name and underscore and sampling, and select 2 of the 4 sampling strategies that we presented in the video and develop a scenario demonstrating how they would be used. Include in each strategy population size, sample size, and demonstrate how the individuals will be selected, and use the examples or the scenarios presented in the video as a model of what you should include. And then please email your assignment to me at happyj1939@yahoo.com. And thank you very much. Oh, by the way, I've explained this in several videos, but the idea is to make these videos accessible to everyone. So when they are put up on YouTube, they generally have the closed caption, and that, pardon me, is for people who might have difficulty in hearing acuity. And I also read the content. Now, I realize that may be boring for you all, but that's to address a visual acuity types of situations so that people with visual difficulties will have access to the videos also. So that's why they are read to you. Not that you can't read. I know you're very intelligent people, but it's in an attempt to make them accessible. So thanks very much, and we'll see you next time.